Good evening, everyone, and I'm really sorry for not being able to present this live at the conference due to the current energy crisis going on in Sri Lanka. So, moving on, I'm Harini Vimalraj, and our paper ID is 257, and the title of our presentation is Automated Programming Assignment Marking Tool. So, coming to the introduction. If you consider the project description, so why marking automation is important. So because mainly it reduces the time and cost of manual marking. It checks for plagiarism. It's easier to check for plagiarism when the marking is automated. It's easier to mark and calculate grades, to provide a feedback, and also it improves the accuracy of marking. So the research problem we are addressing here is the increasing number of students enrolling to programming modules. It's because there is a larger number of students who is enrolling currently to computer related degrees, and as you can see there is like a larger number of students who actually do coding assignments. So when you mark coding assignments, it's becoming highly tedious for the limited amount of staff available. And also if you consider the marking rubrics, as you can see, they provide marks for programs which are not syntactically correct but also have like good coding practices. So in that case, source code analysis becomes mandatory. And also to check for plagiarism, it's important to automate it. When you consider the main objective of our research, it's to automate the marking of object-oriented programming module by converting the source codes of the lecturer and the student into parse trees, extracting features from them, generating a feature vector, comparing those, and generating a mark and a grade along with a plagiarism report and a feedback. So these are our sub-objectives, which has been divided into 4 components, which is converting the source codes into parse trees and extracting features, generate a feature vector, and then generating marks and grades, checking for plagiarism, and providing a feedback. Coming to the related work, so the research gap. So as you can see, there are several other tools currently in existence which sort of have a lot of things in common to our particular system, especially Gradescope. But the difference between our system and the Gradescope is basically Gradescope initially performs black box testing, and if the system fails black box testing, it does not continue to go on and perform the source code level analysis. So in that case, there should be a manual intervention who has to interfere and complete the marking process. So because of that reason, it is not an effective way. It's not a full automation process. So in our system, we will continue to perform source code level analysis even if black box testing fails. Then if you consider some of these existing tools, they use mainly the test case based approaches. So test case based approaches is considering the number of test cases passed, which is not an efficient method because there can be source codes which have passed a lot of number of test cases, but they can be highly deviated from the actual answer. So it's the same. So when it comes to compilation based approach also, like it checks whether the syntax errors are there or not and provides grades, which is not a very efficient way to provide marks for students. So our system will perform source code analysis as well as black box testing to provide a more accurate mark or grade to the student. When it comes to the methodology used by us, so the first thing we did was to conduct a survey. So as you can see, we conducted a survey. By the survey conducted for around 100 responses, as you can see, about 90% of the staff requested for an automated marking tool because, as you can see, like there's a larger number of assignments which are coding assignments in computer related subjects, around 50%. And also one of the common reasons they suggested to automate the marking is to minimize the marking time, the cost, and also especially the inconsistencies which occurs during marking even among the same examiners or among different examiners. So the project scope based on the survey, as you can see, like most of the lecturers, they preferred the automation for a language like Java, which is the language of implementation for the object-oriented programming module. So our solution would be to automate the object-oriented programming module marking, which has Java as the language of implementation. So this is the overall system overview diagram of our system. So initially the student logs in to the interface and uploads their answer script. So that source code gets converted into a parse tree and some features are extracted from it and a feature vector is generated and stored in the database. Similarly, when the lecturer logs in, he too uploads his answer script, which gets converted into a parse tree. Features are extracted, a feature vector is generated and stored in the database. Then the lecturer can select the comparison type as to whether it's exact match or functionality similar. So based on his selection, the comparison will happen. So the marks generated will be different based on his comparison type. So marks is generated along with the feedback report and a plagiarism report. So the first function, which is conversion of the source code into parse trees, extracting features and generating a feature vector. So as you can see, initially, in order to convert the source code into a parse tree, so the lecturer and the students, they both are requested to log into their respective dashboards and upload their source codes. So these source codes are converted into parse trees using the Antela parser generator with a Java grammar. And then this parse tree is taken in and it's converted into a numerical format using the word embedding model. So first thing, they are tokenized by using the spaces, and then these tokens are passed into the word embedding model. So the GenSim tool has this word-to-vec algorithm. It will convert this into a 2D matrix. Then this 2D matrix is passed in through the bag of words model to generate a feature vector. So the second function is to generate the marks and grades for the students by comparing these vectors. So initially, once the script is uploaded and the lecturer selects a grading method, whether it's similar functionality or an exact match. So first thing that the system does is it checks for syntax errors in the student's code by using the Antela error listener. And after that is done, the two feature vectors are compared using a Siamese network, which is built using two identical recurrent neural networks. And then these two feature vectors, after comparing, the similarity is obtained by using cosine similarity. And based on that, a mark is generated and eventually a grade is given to the student. Then to provide a feedback, we use the weighted rule-based approach. So once the student uploads this on script, what happens is it's tokenized again based on spaces, and there's a set of rules. Based on the rules, a sort of a predefined set of rules, a feedback is provided. Coming to the plagiarism, so here the plagiarism is calculated among different students, and not with the internet, but among different students whether they have copied. So here what we're using is the way calculate the weight of the words using term frequency and inverse documentation frequency. And then using cosine similarity, we compare words to find similar words, and overall a report is generated where actually the percentage copied from each student is denoted, and the overall percentage is denoted by a color. So if it's less than 25%, we use green. If it's less than 50, it's blue. If it's greater than 50, it's red. Then coming to the results area. So the first function, where the conversion of the source code into parse trees, extracting features and generating a feature vector. So initially the source code is uploaded. Then it is passed in through the Antela parser generator with a Java grammar to generate a parse tree like this. And then it's passed in through the word embedding model where the GenSim word-to-vec function acts upon it and the 2D matrix is generated. And overall, once it's passed through the bag of words model, a feature vector is generated, which is a range of values between 0 to 1. So during this conversion of source code to parse tree, we use the Antela parser generator because the Antela parser generator had very less side effects due to ambiguous grammar, and also especially it facilitated evaluation on a preferred order with a very high level of accuracy. And then when converting the parse tree into a feature vector, we use the word embedding model mainly because it retained the semantic word meaning of words, and also with this minimum sparse vector and a small embedding vector compared to count vectorizer and TF-IDF vectorizer. These were the advantages of using the word embedding model. Coming to the second function of generating marks and grades. So initially when the lecturer and student's answers are uploaded and a grading method is selected among these two, which is an exact match or a similar functionality. So based on that, the output generated is, when it's an exact match, it's a different score. When the functionality is similar, it's a different score. So this was during the model training, the different grades generated when it was the marks predicted by the human and the grading model. You can see the accuracy and the differences. So when comparing feature vectors, to compare the two feature vectors, like we used Siamese neural networks, which use two identical recurrent neural networks. So it has same trained parameters and same complexity and same number of layers. So RNNs are much suitable here because it's more suitable to handle temporal or sequential data. Then to measure the similarity between the two feature vectors, we use cosine similarity. Why? Because if you consider cosine similarity, it measures the angle between the two similar objects rather than the Euclidean distance. So if you compare the angle and the Euclidean distance, smaller the angle, higher the similarity. So it's more accurate to consider the angle rather than the magnitude in distance. So that is why we use cosine similarity. Coming to the feedback generation, so this is how when the source code is uploaded, this is the student's code. When you pass it, like when you submit it, this is how the feedback is generated. The line number where the error is and the exact error is denoted in words. So it's clear for the student to identify where they have gone wrong. So when generating the feedback, we generated it based on conditions. So here there were some limitations. So when there are more than one classes, we couldn't proceed. And also like when the semicolons were not added properly, it was a little difficult to provide a proper feedback. So coming to plagiarism, so in plagiarism, this is how the outputs were when it's like less than 50% and when it's greater than 50%. So we display the percentage copied from each student separately and the total percentage. So when checking for plagiarism, TF-IDF was identified as the best way to measure the weights, and cosine similarity was the best to compare the different objects or words. Coming to the conclusion, overall conclusion. So the grading process of this full system is fully automated of our system. So the overall grading process was improved to sort of give more accurate results by following two methods of marking, where we did black box testing and source code level analysis, and we provided a score which was a summation of both. So it is highly accurate, and also we provided more additional facilities like feedback and plagiarism, which is not there in some of these existing tools. So when it comes to the future work, so the scope of this project, it could be highly extended further to Java projects which has like more than one class file, and also for projects with different languages like Python, C, C++. So our aim is to improve this project further to support these situations as well. Thank you for patiently listening to my presentation. Have a great day.